Hello and welcome everyone to Learning Decoded. This is going to be a new series on data structures and algorithm. We are going to cover each and every data structure. In the complete series, we will understand each and every data structure in depth and we will go through the implementations as well. Today, in our first lecture, we are going to start with the basic implementation of our first data structure type, that is arrays. So, what is an array? An array is basically a collection of items stored in a continuous memory location. All the items are of similar data type. Let us understand what it means. So, say for example, we have defined an array of size 10. So, size means it would be able to store 10 different objects of the same data type which we have defined. So for example, let us say integer array of size 10. This is how we implement, or we can say we define an array in C or C++. The first part, it defines the data type which we are using, which we are giving to the array. The second is going to be the name. Say for example, here we have used array, which is the name, but we can change it also. Like we can name it anything. For example, we name it as B, only B, for convenience and for better understanding. Let's move forward. The size 10, what 10 means? Let's reduce the size to 5 so we can fit it in our screen. Say this. There are 5 blocks which I have shown here. When we define an array, we basically point to the first memory location where we will store our data. Now the memory is allocated to this array B. This size has been allocated, this whole size has been allocated to it, and whatever we are going to give to our array, it will get stored in these 5 blocks. Here we have a special naming convention which starts from 0 order. So the index of the first element is going to be 0, then it is going to be 1 and so on. So the last element will have an index of n-1, where n is the size of the array. So here n is 5. Then our last element, which is going to have an index of n-1, that is equal to 4. So this was what an array looks like. Now what these blocks are, let us get in depth to it. So each block will have a memory size of the data type which we have defined. For example, here we have defined integer. So this 0th block, this whole block will contain this whole block will be a memory that can store an integer. So here, if this is our first 0th element from the last B array, then we can save anything which will fit, any integer which will fit in the bounds of int. So say for example 0, 1, 2 or anything, we have defined here 100. So now the 0th element is basically 100. How we can give or store data? To store data, the array which we have defined, it was named B. Now if we want to externally give data after we have created the data, we have created the array, then we can do it by simply calling the name, that is B, giving a square bracket and a position index in between there. For example, if we want to show something to this location which is of index 2, then we will give here 2, then we will put an equal to sign, which means in array B at position 2 we are going to store something. That something is equal to what we will define here, say 25. So now once we do this, 25 will get stored here. This is how our array basically looks like, and by this we can externally give the data to it. Now, understanding how and why we use an array. So as we have understand, array is a continuous allocation of data memory for storage of data of similar types. The name from our last example was B. What the name does, it is basically a pointer to the very first element to the memory block. This 0th index, this B name will point to this 0th index. Now, why we use array? Because when we need to fetch the data from any location in this range 0 to 5, which we have defined the size, if we want any of those data, we can do it in order of one time, that is in a constant time. So, say now we want to fetch the data which is stored at location of 2, which was 25. We just need to do B of 2, print it. When we print it, it will go to B. Here it is initially. When we give 2, it will bounce or jump 2 steps ahead, and by calling this in the square bracket, by this method, the data inside it is fetched. So it will print 25 to the screen. This operation or this fetching of data is a constant type operation, and the memory allocated is a continuous memory. The name here is a pointer to the first element. All this are the key points which we need to keep in memory whenever we use an array. And that is why an array is one of the most used data type which we will see in our day-to-day operations. Now, we can in another way also define the data. Say our example, we are creating an array. Let's name it as learning decoded. The data type it will show is an integer, and the size is of 5. So now this 5 size array, learning decoded is pointing to this. This learning decoded is a pointer that will point to the very first location, that is the 0th index. Now, if we want to give it a data, to give data to it initially while creating, we can do it there also. We can do it there also. So, by this method, we have given the data while we have created it. So now, what will it store? 2 at the 0th, 5 in the next, 10, 20 and 25. This is 0, 1, 2, 3, 4. So these are the indexes. This was all about the array data type. One key point that we need to remember is the fixed size. Whenever we define an array, the size of an array is fixed. Here we are defining it while creating. We have to explicitly define it. Here we have given a size of 5. It can be any size. So by size, what it will do, it will create a continuous memory of the size of 5. One key point, apart from integer, say we have a class of type node or struct of type node simply. This will store integer value and a pointer to the next node. Now, if we want to create an array of nodes that will contain nodes, we can do it simply by giving the data type, that is node here, then giving the name say we are giving the name array itself and then giving the size. Say for example here we are giving only 3 size. So now what it will allocate continuous memory, and array will point to the very first. Then this whole block will be of what size? So here, as we were using integer, the size was in the range of integer that could contain an integer. But now here, if we are defining a node which is our defined data type, it needs two different things. First is an integer, second is a pointer. The combined memory which will be required to save these two datas will be the size of this node data type, and that memory will be the size of every block in the array. Hope you understood. The concept of array, the fixed size of array is a kind of limitation in implementation, and when we are using an array, we require sometimes a dynamic array which can store as much data as we want, and it could increase its size on itself as per our requirements. These things are not satisfied by the normal array which we have defined here. So what we will do, we will jump to the next topic, which is going to be vectors. Vectors are arrays of dynamic size, not of fixed size. And in the very next video, we are going to understand vectors in depth. Thank you and keep learning.